Okay, so we've run Hello World. Pretty straightforward program. Let's do something a little bit more complicated. We're going to talk about this program that converts Fahrenheit temperatures to Celsius temperatures. It's nothing groundbreaking, nothing earth-shattering, but it is going to give us a chance to talk about some important things. A couple of those are importing classes that other people have written from different packages. We're going to talk about assignment statements. We're going to talk about variables and objects. But first, before we do anything, let's actually just stop and look at the program. This code is on the class website. You can download it, pull it into Eclipse by importing it into a new package, and then you can actually run it. So let's take a look real quick and see what happens when we do run this. So click run, enter degrees Fahrenheit. Okay, well, we'll say 32 degrees. Okay, that's 0 degrees Celsius. Whoop-de-doo. Okay, let's do another one. Enter degrees Fahrenheit. All right, let's say 98.6 degrees Fahrenheit. That is 37 degrees Celsius. Fantastic. It works, makes sense, we're good to go. One note right here, in this program, in Eclipse, it's going to give you a warning. This is not an error message, this is a warning. Resource leak, reader is never closed. Don't worry about this for now. We can talk about it later, but don't worry about it. It's not a red X, it's the little exclamation point, so don't freak out over that. Let's come back here. This is the code we just looked at. It is pretty straightforward, but there are a couple things here that are new that it'll be good for us to talk about. If you take a look at this very first line, import java.util.scanner, essentially someone somewhere has written a class called scanner. A scanner is a type of object. If you remember from the role play we did with objects are they're things that do stuff. You could have a teacher, and one of the things it does is assigns homework. You could have an acrobat. One of the things an acrobat does is it does backflips. Well, you can have a scanner, and one of the things a scanner does is it reads input from the keyboard, and that's what we're going to use it for. So here we have a class called scanner, and someone has written that class and put it in a package of related classes called java.util, I guess for utilities. And we're telling our program, hey, I'm going to need this scanner class from this package java.util. I'm going to need that. Great. Next thing we want is to look at this very first line. Oh, so let me step back. Obviously, we have our class. This program is called convert, and we have our main method. But the first most important line here is scanner reader equals new scanner system.in. Again, what we're saying here is, hey, I need a new scanner object. It's going to need system.in. System.in means the keyboard input stream. That's really what it means. So, hey, I'm going to make a new scanner object, and it's going to need to use the keyboard. I want to be able to point to that scanner object that I make with a variable called reader. That brings us to the point of instantiation and what that means. So I just mentioned instantiating an object. That means creating an instance of a class or creating one particular example of a class. In the last situation, we were talking about creating a new scanner object. Here, if you look at the examples below this yellow line, we're saying, hey, I want to make a new bike object, and its color is red, and I want to call it my bike. Okay, you can see these statements are basically read right to left. Hey, I want to make a new student. This student has first name Carl, last name Chen, ID number 573819, and I want to refer to him as student 1 or stud 1. This is the same example as we have on the in the convert program. Hey, I want to make a new scanner object. It's going to use the keyboard, and I want to refer to it as reader. And it doesn't have to be named reader. So, hey, I could make a new scanner object. It's going to use the keyboard, and I could call it arbitrary name. I could make a variable that refers to that object, and that variable is called arbitrary name. Likewise, I could say, hey, make me a new teacher object. This teacher has he's handsome, he's beardy, and I want to refer to him as Paul. So these are all examples of instantiating objects. They generally follow this format. Well, hey, make me a new whatever the class name is and whatever parameters it takes. So whatever characteristics you're giving that object. Now, whoever writes the class, whoever writes the definition of that type of thing, whether it's a bike or a student or a scanner or a teacher or whatever, whoever writes that definition gets to decide what types of parameters it takes, whether it takes a color or a name or a string or a number or a temperature or adjectives or whatever else. We're saying, hey, give me a new example of that object, a new instance of that object, and I want to make a variable that points to that so that I know how I can refer to that object I just made, and this is the name I'm going to refer to it by. So again, system.in is it deals with the keyboard, and that's really what its main use is. Okay, next two lines, we haven't talked that much about variable types specifically, about data types specifically, but for now, what we're doing here is declaring two variables. We're saying, hey, I'm going to use one variable called Fahrenheit, and it's going to be a double type. That's the type of variable it is. And I'm going to use another variable called Celsius. That's also a double. Double is a variable type that we can use to hold decimal values. So that's what it's there for, as opposed to an int, which holds integer values. So here we're declaring two variables, saying to the compiler, hey, we're going to use these two variables. We'll talk more about that later. Here we're printing a message to the reader, enter degrees Fahrenheit. Notice we use print, not println. What do you think would change if we used println? I think you know. Next line. It's helpful to read these statements from right to left. Okay, so we're saying to our scanner object, hey, reader, use your next double method. Now, you've never seen the specifications for the next double method, but it waits for the user to type in a number. And whatever the user types in then gets stored in whatever variable we stick on the other side here. So what we're saying is, hey, reader, get a number from the user, from the keyboard, and store it in the variable Fahrenheit. Great. Easy enough. This is an assignment statement. We're using the assignment operator. That's what that equal sign is. So this is important. Assignments happen right to left. Okay, the value of the thing on the right gets stored in the variable thing on the left. Okay, so that's not the equal sign like in math. The equal sign in Java is the assignment operator. Okay, it may be easier for you to think about it as it gets. So you can say the thing on the left gets the thing on the right. Whatever helps you not get confused. The single equal sign is the assignment operator. Okay, and the next line here is we're looking at a little bit of number crunching that's happening. Again, let's look at this from right to left because we do have an assignment operator. So the thing on the right, we're saying, okay, take whatever the user entered in, because now that's sitting in Fahrenheit, subtract 32, multiply by 5, divide by 9, and whatever you get, store it in Celsius. Right? So Celsius gets that. In that math that we just did, we follow the order of operations, parentheses, exponents, multiplication and division, left to right, add and subtract, left to right. There's tons of other operations. You know, we can show you here. There's really detailed operator precedence or order of operations. Here's some more. Here's some more. You can look at those on the slides later, but we're going to talk about a bunch of them. But for now, just know that there is a really well enumerated order of operations in Java. So we've got our new Celsius value in the Celsius variable. Then we want to say, okay, print in Celsius, that is, notice again here, we have print, not println. And finally, we print ln the Celsius variable. Okay, so we can see this is going to print our temperature on the same line as that in Celsius that is, and then it's going to add a new line. So this is an important thing that comes up when we're looking through this program. We see sort of two types of things. We see variables and we see objects. Okay, so Fahrenheit and Celsius are both variables. They both hold a single floating point number. Floating point is one way of storing values with decimals, so values that aren't integers. So Fahrenheit and Celsius, they're doubles. They both hold, decimal numbers. Okay. Reader and system.out are also variables, but they hold references to objects. Remember, I made a new scanner object, and then I just said, okay, well, I want to point to that new scanner object I made with a variable called reader. Okay, so I've got a variable called reader that's referring to a scanner object. I've got a variable called system.out that's referring to an output object. Okay, and those objects are the things that have the methods that we need, the print, the println, the next double. If it's helpful, maybe you want to think of objects as sort of bigger than regular variables. We'll talk a little bit more about this in the future, but that may be a helpful way for you to think about it. We're using reader, our scanner object, without really knowing that much about it, except that it responds to the command next double. We don't know anything about how next double is implemented. We haven't seen the code for next double. We haven't seen what specific things the programmer who wrote it decided to do. All we know is, hey, this is what it does, and we're going to trust it. Okay, so that means somewhere, well, really we know where, it's in java.util, there's a scanner class that somebody wrote, and it's got a method called nextDouble in it. Now, this is really important because what this shows us is the principle of information hiding. We're using that scanner object without knowing exactly how it works. That's really powerful because that means that we can later write things that other people can use without them having to worry about how we did it. As long as they can trust that it works, as long as we've tested it and we can guarantee that it works properly, well, they don't have to know, the nitty-gritty of how something is implemented. Information hiding is really helpful. So example, if I go to an arithmetic object and I say, hey, multiply 4 and 5 for me, please. Hey, there's a ton of different ways to do this. Oh, there's not a ton, but there's 3. You could add 4 5 times. You could add 5 4 times, or you could just multiply 4 times 5. We don't know, we don't care which way multiply does it. That's all hidden from us. I just call the method and I get the answer. So information hiding is really, really powerful and useful in that sense. It also means that maybe I realize partway through my project, what, adding 4 5 times is not really helpful. I want to go ahead and change that to multiplication. It means that I can go and just change that one particular method rather than changing every time I multiply 2 numbers. Okay, so before you close up shop, couple things I want to make sure you understand. Go back through and look at the slides. Go back through and re-listen to the video if you need clarification. We want to make sure you can distinguish between a variable and an object. Want to make sure you can understand and define what instantiation is when you instantiate a new object. Want to make sure you can actually instantiate a new scanner. We want to take user input with a scanner object and the next double method. Want to make sure you can use the assignment operator. And tell me what's information hiding and why is it helpful. So I would encourage you, take a look back through these slides, download the convert code, open it up in Eclipse and run it for yourself. And we'll see you next class.